Hello, welcome to Technoveda Solutions. In this video, we will discuss about function overriding. Okay, so we know that function overriding comes under runtime polymorphism. Already, we have discussed compile time polymorphism. So, if you are not seeing those videos, I will be giving the link in the description box. You can watch those videos as well. Today, we will be discussing about runtime polymorphism. Under that, first one is function overriding. Let's see how it works. So, function overriding is a concept of redefining the base class function in the derived class. That means we have already defined a function in the base class. We are again redefining the function again in the derived class. Maybe we want some addition to the function, any modifications to be done, that also can be done, and we can redefine that function in the derived class. Now, depending on which object is calling the function, based on that, during the execution the respective function will be invoked. If the base class object is calling, then base class function will be called. If derived class object is calling, then derived call function will be called. And we also know that in the derived class we also have a base class function also available, provided it is either in the public or a protected mode definition. Only if we define it in the private, it cannot be inherited. In other cases, it gets inherited to the derived class. Okay, so this is how we define that in the code. So we have a parent class or the base class, and then you have a access modifier, that is the public or protected should be, so that we'll inherit that, so that we will be able to observe the overriding of this. If you make it protected, it will not inherit, so we cannot observe the overriding mechanism. Then we have a function which will be overridden, that is the return type function name. The same function will be redefining here, which will be overriding this function. This is the overridden function, this is the overriding function, which is either in the derived class or the child class. So this parent and child are the nomenclatures used both in C++ as well as in Java. But in C++, we can also call them as a base and derived class. So I'm giving you both the analogies so that we can call in the different context. You may come across different nomenclatures. So both are same. Whether it's a base class or a parent class or a derived class or a child class, it is still the same meaning. Child, that is inherited class. Base is which is inheriting the derived class. Okay, now we'll directly go to the code and check how exactly the overriding is. Okay, coming to the code, now we'll see how it is implemented and how we define that. So header file, namespace definition, and then I have declared a couple of variables for the operation. So all are integers. So that is in the private mode, access specifier or a private mode. Then under the public specification, I will be defining the constructor. This is the constructor which is having the same name as a base class. And in the constructor, all we are doing is just initializing these variables. All we initialize it to 0, and we just give a message saying that base class constructor is executed, so that we'll know that whenever we create an object, the constructor is automatically invoked. Just we already seen that, so it is retained the same concept here. Then this is another function which is defined for overriding in the derived class. So it is also on the public, so it will participate in the inheritance. Now here all I'm doing is just adding the v1 and v2, two numbers what we are passing, that we are adding, and result I'm displaying it. Only the thing is I am saying that base function, which function is being executed, to indicate that we have given base function, sum is displayed here. Then I'm inheriting that class in the derived class, so I'm giving a name as a derived itself. So class the keyword derived, then you have a public inheritance and from the base class. So all the public members of the base class will be inherited to the derived class. Now in the derived class also, this is just a constructor. I'm just defining a constructor to initialize all the variables to the 0 and display the message that derived class constructor is executed. Then the same function what we have defined here, same function I'm redefining here. with the r1 is equal to v1 plus v2. Only thing is this message I am giving is derived function sum. So here I have given a base function. In the derived class I am giving derived function, so that we will know which function is being executed and when. Now then in the main program I am defining the object for both the classes. This is a base class object, this is a derived class object. Then I am calling the same function add, once using a base class function, once using a derived class function. Okay, so this which has to, I expect to call the derived class function, and this I expect to call a base class function, because those objects are calling that. This is a base class object and this is the derived class object. Okay, so let's compile and run the program. So now you can see here, first we have a base class constructor being executed because this object is created. Then we are creating a derived class object. Even then the base class constructor is executed once again, so that the function what we inherit should be able to execute. So there will be another base class execution happens when we declare a derived class object also. Along with that, derived class constructor is also executed. Okay, so observe here, this is base class object, so base class constructor is called, and when we create a derived class object, both base class and derived class constructors are called. Then when we call a add function using a base class object, that respective function is being called and we are getting the output of the sum of two numbers what we are passing. And when I call a derived class add function, I am getting the result from this function, that is derived class function. So we can see derived function is sum equal to 30. Even though the base class function is also available in the derived class, but we are getting output from the derived function because this function overrides the base class. But how do we know that that function is available here? Okay, so for that we will just comment this. Okay? And now if we execute, now we can see that when we even calling the function using derived class object, then also base class function only is being called here. We can see base class function is called twice because there is no overriding function in the derived class. If I uncomment this, this function is called. If this function is not there, then anyway we have a base class function available in the derived class, that function will be called. So this is the overriding concept. But here if I uncomment here and if I comment this, now what happens? There will be a problem. Now you can see that this particular add function is not defined, has no member, because this is defined in the derived class. We know that the base class functions will be available in the derived class, but derived class functions are not available in the base class. That means this base class object cannot call a derived class function, but the derived class object can call a base class function. Okay, so if I comment this, it will give an error. So we need to have this function in the base class because we are using base class object to call that function. Okay, so this is how we do the function overriding. We can do that in different inheritances. We can have any type of inheritance and we can override it any number of times. So always the function which is defined in the respective class, native class, will have the highest priority. Whenever we call the function using any object, it will always try to find that function in the class to which that object belongs. Only if that function is not available in that class, in that case only it will try to get the function from the parent or the base class. Otherwise it will always execute from its own native class. Okay, okay, so that's it in this video. Please like the video, subscribe to the channel, and share the video it with your friends. Thank you. Have a good day.